materials the government has spent the weekend scrambling to secure to protect the short-term future.
Okay, so this is the Scunthorpe Steelworks plant.
Keeping the home fires burning matters because if these furnaces go out, the plant is dead. With fresh supplies of iron ore en route from Australia and coking coal from the United States, the Deputy Prime Minister is confident it has a future.
We've got the raw materials, they've been paid for,
Oh,
and
no.
we're confident that the furnaces will
Oh, dear.
continue to fire. We've taken the action we've taken over the weekend. It was important that we did that. We secured the site.
Okay.
Having seized control of the company from its Chinese owners at the weekend, the Prime Minister met new Chief Executive Alan Bell on the right
okay.
here. He will work alongside a team from consultants.
So they seized control of this company from the Chinese owners. This is very interesting. I don't know what exactly that means. Yeah, I don't know. We'll see. But apparently they've bailed them out. So.
And a long-term plan likely to start with nationalisation.
There's still a lot of discussion that needs to take place about what comes next. You know,
so they want to
what
make
plans
this
under this new rule of the Labour Party, the Labour government.
They want to make this public.
So we're still waiting to get that detail as to what's going to follow after the weekend. But yeah, I think it's safe to say that we feel a lot more secure now than we did before.
Locally, there's relief that the plant and its 2,700 jobs have a reprieve.
It's having a real big impact. Our business has gone down by about 60% for the guys not coming out.
So my partner's worked there for, I think, about 2 years now. So we still don't know what the outcome is. We're still in that random space of, do they have jobs? Do they not have jobs?
I mean, if they want to make this public, right, we have to buy it off of them, the Chinese owners, and then somehow, I mean, Britain doesn't build anything these days. Britain doesn't really know how to build things. It's very, very different to China. If we wanna take this over, this will be a big thing. Because it will be a great step forward for us, I think, to be able to produce our own standard forms of steel. Like you can see here, they're making like steel wire. So it would be quite good if we had this and we actually did something with it. The problem is, I don't trust, like I don't have the confidence in the public sector to oversee this correctly. And to do this efficiently.
Their intervention is justified because only coal-fired Scunthorpe can produce the virgin steel used from railways to defence. But government support for Tata Steel's Port Talbot works...
Yeah, so... Let's just go... Hang on, what was it? What did they just say?
Justified because only coal-fired Scunthorpe can produce the virgin steel used from railways to defence. But government support...
It's used in a lot, and I suppose if they did let this close down, we'd have to buy in all of our steel from other countries that are producing the massive amounts of steel, like China, India, some other countries. Australia has a lot of mining industry there. So, but that's the thing, like, even if we got the raw materials for the steel, we won't have this plant, if it does close down, to refine it into the standard form. So you see here.
For Tata Steel's Port Talbot works,
and Port Talbot, I think, wasn't that closed down? I'm pretty sure that was closed down.
Transition to electric arc furnaces fed with recycled steel, a potentially more sustainable alternative.
Okay.
We've got the feedstock here. We don't have supplies of coke and iron ore, but we do have our own scrap.
Okay, so they're going from coal to electric arc. Electric arc is still a bit messy. I think induction, even though it has less efficiency, induction would be it's less messy. The electric arc furnace, I'll show you here. And it's quite, like it is quite messy. These things are loud. They're difficult to work around. If you change that to induction furnace, these are very slick. These are very modern. you put the materials in, and then it literally, you just turn it, you turn the whole thing, and it pours out into the crucible. Very easy, a lot less mess. It is unfortunately, it's unfortunately less efficient because it's induction. Let's see if we can find a video here. Yeah, why not?
Ever wondered how steel is melted
Ooh, don't want that.
and processed
So
heat within a conductor?
let's just turn that off. See if we can't find something actually good. So this is the arc furnace here. You can see it's messy. Port Talbot Steelworks. I'm pretty sure that closed down. It's the largest steelworks in the UK. Did it close down? Yeah, shut down the last blast furnace in September 2024. Okay. So if they're planning to replace this with electric, this will be very
So
very
we could be
interesting.
operating in a closed loop, powering it with renewables or nuclear, and then we would have a green, clean steel industry, which is categorically the way of the future.
With Scunthorpe
It's-
losing 700,000
It's not even the way
every
of the future. It's the way it's done now, and you've just got these
day,
big
Donald Trump's
legacy
trade war
plants
deflating steel price.
that they're old, they're less efficient, they're messy, and
Prices forging
it costs
a
money to
long-term
redevelop
future
this.
for the British steel industry remains an enormous challenge. Paul Kelso, Sky News.
Okay, interesting. And then this is like an aerial shot of the site. I don't really know what else I have to say about this, really. The UK doesn't manufacture many things anymore. The UK doesn't really know how to build stuff as well as other nations, like in terms of stuff, I mean infrastructure. Things cost a lot of money. Things don't get done as fast as other industrialized nations. So it would be good if we don't lose this. But as I say, I don't have any confidence in how it's going to be run in the future. So I still think a lot of our proportion of steel is going to be imported from other countries. That's just how it is. It's just how it is. And notice they're using coal here as well. They're using they said coke earlier in the video, didn't they? So I think we shut down our coal mines as well, so we have to import the coal anyway. So the real the real thing that we have to do is get these moved over from coal to nuclear, change the whole architecture of these furnaces from like you said, coal fire or coke fire furnaces into electric induction furnaces. And I think I've got a big energy mix here. We'll see if that actually loads. And this is just a chart of the energy mix consumption. We'll move it so it's post World War II, and you can see here coal is still a big contributor to the world's energy mix. And moving this over to nuclear, it's less emissions, it's less messy, it's nuclear is a lot more stable. There's a lot less supply chain that's involved in terms of, and by supply chain I mean like just getting the raw materials into the energy plant. Same with natural gas as well. So I'll show you here the natural gas cost of running these gas-fired power plants in the UK are actually quite high. So even though gas itself is quite cheap, when we have to spin up these natural gas electricity plants, it actually brings the whole cost of electricity in the UK up. And I think there's a website that allows you to see. I'm just trying to remember what it was. Yes, so UK National Grid online. Not that one, it's that one. Perfect. So this is National Grid Live. This is the UK grid as it is right now, and these are the stats. And let's see here. So yeah, so currently we are generating 3 gigawatts of gas. Most of it's coming from wind at the minute, which is great. If we look at the past week, we can see 6 gigawatts approximately have come from gas. And whenever these gas-fired power stations are on, they drive the price up because I believe there's a tariff situation, not an international tariff, but I think it's called a mixed tariff. I'll have to have a look at that. But basically, it sets the price of electricity on wholesale as it's the highest price there. So gas is the highest price. So when you buy electricity that may come from wind, which is actually quite low price, it's at the price of the gas power plants. So yeah, that drives up costs for consumers as well. So also, I think just down here, we can have a look at the different kind of, we'll pause that. I've lined up a few videos as well to see. But we can see here, Sweden is actually using a ton of nuclear, as opposed to, let's say, the UK, which we use a lot more fossil fuels. There are, I think, a couple working nuclear power plants in the UK, and the rest are from renewables and wind. And I think wind is actually quite well done in the UK. It's quite useful. But looking at Sweden, looking at France, you can just see the massive, like a much bigger proportion of nuclear energy coming from there. Now we've got Hinkley Point C. Now, Hinkley Point C is going to come into effect in 2029, between 2029 and 2031. But it is being contracted by EDF, and if I get a little video of it, we'll have a look.
I'm Lily. It all started for me in 2018 when I became an apprentice at Hinkley Point C.
Turn that down a bit.
Morning. Can I order a latte, please? I wanted to follow my dad and granddad's footsteps and build a nuclear power station. Morning. That first time I went to site, we'd barely started. It was almost impossible to imagine then how far we'd have come. And 2024 has been another year of incredible achievements. So this is my office, and this is what we call Unit 1. This is one of 2 reactor buildings that would be used to generate nuclear energy needed to make electricity.
So they've split the reactor design. They're European pressurized water reactors, and there's 2 of them. I believe each one is 3.5 gigawatts electric.
As an apprentice, I helped to build the base that sits on. Today I'm supervising my own team that install all of the concrete equipment. This
big dome here, if I just reverse this, you can see the large concrete dome that's designed for aircraft strikes. So if an aircraft is ever hijacked and is flown into the reactor building, this dome is designed to protect the reactor inside.
Supervising my own team that install all of the concrete equipment around site. So my career's grown just like the building. I just bought my first house when the dome went on last year. My house was a big step for me, but the dome was massive for everyone on site. Since then, we've been busy getting this power station built. Now we're installing the heart of the power station.
So you can see a lot of the parts are manufactured off-site and then shipped in, which I think is the way to do it. Unfortunately, they're using way too many companies, way too many contractors. I think it's something like 2,000 different companies that are involved in this project. It's not streamlined whatsoever, and you can see here it's just a large scale operation. It's a big
huge
plant
steam
they're building.
generators. Builders like
There's a lot of money, a lot of funding behind this.
have finished hundreds
But
of
bear in mind, this is only 3.5 gigawatt electric. It's not the potential that nuclear energy can
rooms where
provide.
electricians and welders are installing thousands of pieces of equipment. And behind all of us here on site, there are 22,000 people throughout the UK,
22,000.
busy making all of the parts we need. The transformation of the turbine hall this year has been incredible.
Okay, so here we go.
I just completed my MVQ level.
So let's run that back. So this is the turbine hall. So this, there we go. So this is the turbine hall. So this is where the big steam turbines are going to get put in. Essentially, we're going to take the heat from the reactor and put it through a massive boiler. It turns it to steam and runs it through this conventional steam turbine. Now, these steam turbines they're huge. They require their own, like, it's its own building, right? Unfortunately, I think the efficiency of power conversion for the steam turbines, I think, caps out at about 50%, I believe. However, there's a better technology around called supercritical CO2, and that takes it's essentially the same thing, but it uses CO2 as a working gas rather than steam, and it takes the size of the whole turbine down by a factor of 10. So this whole turbine assembly could be basically 10 times smaller, and as a result, cost less money to build such a, you don't have to build a big space like this, and you get, I think it's a little bit, depending on your energy recuperators, so the working gas will pass through a heat exchanger, and then you have some recoup modules that will boost the efficiency of it, but it's essentially you'll get similar to a little bit more efficient performance with a supercritical CO2 turbine. Why they're designing this now, I have no idea, but we'll continue
level
on.
3 when the blue columns that will hold the turbine were installed. They're now hidden inside that huge hall where we're ready to lift the world's biggest turbine.
Yeah, there you
The
go.
first 450-ton part of it has
It's
just
huge.
arrived on site.
It could be
It will make
45
electricity
tons.
for 3 million homes.
It could be 1/10 the size, but it's not.
I just bought my first car when we built the base for Unit 2.
So this is the second reactor. So they're trying to do modular design by saying, hey, we're going to build this one, and then we're going to look at the improvements and then build the second one, which is essentially, I mean, it makes sense. It's good.
Ring section into play.
It allows you to build faster, so every time you crank out a new reactor, you know the problems from the last one, and you can get it. Like, it's easier, it's better, it's quicker. Unfortunately, they're planning to do this. So there's Hinkley Point C, but there's also the second site called Sizewell C, and it's basically just a copy. There's, they're building this one first. They're learning from the mistakes, and they're going to build Sizewell C. After that, it's kind of slightly delayed from Hinkley Point C, and
ready for the dome next year. In October, we also installed this giant steel staircase.
It's not quite my paradigm. I prefer small to large and rapid prototyping. So let's say these reactors were 1/10 the size, but you crank them out a lot faster, and you do a lot more research and development in between each reactor, you're going to get a better reactor by the end of 2030. That's just how it is. Unfortunately, we're dealing with big companies and very big, slow-moving companies. That's the thing.
In one piece, helping to cut installation time by 75%. In fact, everything we've learned from Unit 1 means Unit 2 is being built 20 to 30% faster.
Yeah.
And the most important thing to arrive on site in the last couple of years is a load of extra people. When I first started on site, there were far fewer people than you see today. But now there are 12,000 of us working every day, including 1,360 apprentices, just like I was.
I'm glad that there are
like
apprentices
last year,
there.
we saved the best till last.
I'm glad there are apprentices there, but the payroll for how many staff was that? They've increased staff by 12,000?
But now Now there are 12,000 of us
Now there are
working every
12,000.
day, including 1,360
That's a big payroll. That is a big payroll.
apprentices,
But yes.
just like I was. But like last year, we saved the best till last. We've just installed Unit 1's nuclear reactor. It's the first in Britain for more than 30 years.
I think this is about a month ago.
It took real skill and our massive polar crane to get it lifted perfectly into position.
Big crane. That's a hefty crane. If we look at the size of the person being down here, this crane is huge. Very good piece of engineering there. But you can have a look at this reactor. So this is just a scaled up version of your kind of normal reactor diagrams. Inside here will go the control rods and the fuel rods. Unfortunately, European pressurized water reactors use solid fuel rods rather than a liquid fuel, which is it's kind of the better technology. Is you know, you don't fill up your car with coal, you fill it up with a liquid petrol or a diesel, right? It's the same kind of philosophy. It's like the fuel should be liquid. It's just easier to handle, easier to manage. But I mean, at least they're building something, right? So we've got control rods, graphite, we've got the actual fuel rods that go in there, and then there'll be a robot on top that will basically come in, grab the fuel rod, take it out, and then put it aside for servicing.
Polar crane to get it lifted perfectly into position. That's a big deal for the country and a huge moment for everyone on this project.
I'm wondering what these.
I can't believe how much this
these, if you can see my mouse, like these big extrusions here on the side, they've got
country
flanges.
And a huge moment for everyone on this project.
But obviously,
I can't believe how much this place is changing.
That reactor had to be made off-site. There's no way that reactor is going to be built in Britain. I doubt that reactor was built in Britain. That's a huge piece of steel or whatever alloy they're using.
I've come. I'm building a nuclear power station I set out to do as an apprentice, just like my dad, who's a construction manager just over there, and my granddad, who helped build Hinkley Point B. And when my work here is done, I want to take my qualifications, skills and experience to build another at Sizewell. I'm really proud of myself and the life I've made. Building something that really matters.
That's interesting. Okay, so this video is 4 months ago. Okay, fair enough. But I think it's great that they're building something. I think the technology's there that they could build something a bit better. And if we want to take a comparison as well between the difference in size and scale of the project, we can hopefully there's an image between Sizewell B and Sizewell C, because I believe Sizewell C is much larger in terms of the footprint that it takes up. Okay, so I think this side here is Sizewell A, this is Sizewell B, and this is Sizewell C, with its two reactors, Reactor 1 and Reactor 2. That's very interesting. And of course they have to build it on a shoreline. So this shoreline is designed to as a closed loop system of steam running through the generator, and then that whole system needs to be cooled down, especially in the condensers, and so they'll run big pipes out to sea to pull in cold seawater, put it through a heat exchange, put it through the condenser so it can cool down the steam in the closed loop cycle, and then they should just pump the water straight back out again. So the water that's in the steam turbine, that won't ever contact or come in contact with the seawater. It's just kind of, they're both isolated. We remember this guy. So I mean, I'm glad Britain's getting on the nuclear kind of bandwagon, as it were. But unfortunately, like we saw a lot earlier, it's still being built, and it will only be fully commissioned kind of 2029. So we're still 4 years away. And this project has cost a lot of money. It's projected, I believe, to cost about 51 billion. It's projected to be quite a lot of money. And it's just kind of proof to, if we compare our building and manufacturing to China's building and manufacturing, China's just a lot quicker. They will get it done a lot faster. Look at that. We have our first comment. Hello. So what is the size of the well? A stream well, not as good as CO2. Let's have a look. So okay, I don't think that's going to tell us much. Let's have a look. See if we can find the specifications on this turbine hall. Oh wow, this document's from 2016. This is early on in the scale of the planning. Apologies, I have Duck Reader on. I shall turn that off. That makes a lot more sense. So let's find the turbine hall. Okay, so 2 turbine halls, and that's all the mention of turbine in this document. Brilliant. I don't think we're going to get the specifications up. Okay, here we go. So it's 20 meters, 20 meters long, weighs a lot of a lot of kilograms there. Okay, and the final stage blades are 1.9 meters. So this is quite a large steam turbine. So let's compare it, shall we, to a supercritical CO2 turbine. Perfect. So there you go. There's the size of a supercritical CO2 turbine. I don't know what kind of power this thing puts out, but you can see the scale of things. It's just a lot smaller. It's a lot more compact. I believe it's more efficient as well. Here we go. This is a great example. So this is a 20-meter steam turbine. 300 megawatt electric. So we're looking at a similar size to the one that's going to be put into Hinkley Point C. And we take the same, let's say it's only producing, 300 megawatts electric. These steam turbines at Hinkley Point C is doing 3.5 gigawatts. So an order of magnitude more. But the point still stands. The size of the steam turbine is greatly reduced. Sometimes in a factor of 10. Here it's a factor of 20. But yeah, you can see here. It's better for space. I believe the efficiency is higher. Here we go. Oh, here we are. So nuclear reactor operating temperatures should be about, I want to say 700 degrees. But yeah, there we go. So we're getting, at that temperature, we're getting close to 50% cycle efficiency, whereas the steam cycle, so I think it's called the Brayton cycle, Rankine cycle, that caps out at 45, according to this graph. So it is slightly more efficient. It's a lot better in terms of space and cost. And so yes, that'll be a lot better. Why they designed it to use steam turbines, that's just because the company is large. They're not an R&D company, they're just a contracting company. They kind of know how to make it. A European pressurized water reactor, there are standards, there's regulation involved, and so they'll go with what they know, which is a steam turbine. So let's see this. Okay, so it's pulled in by barge. It's a good way of transporting the larger, heavier objects. And this is just the turbine hall, so good British weather. Okay, this is literally just the the crane girders and not the actual turbine. When can we put supercritical CO2 turbines in houses? They do fit. Unfortunately, you need to also generate the 700 degrees temperature to actually make that work, as well as a generator as well. So if we look at the magnetic generators, so alternator generators here, so you'll need, again, something like this, as well as the turbine to produce the electricity. And these are in varying sizes, and depending on how they're designed and depending on the excitation design of the motor, they'll have bigger sizes and they'll have smaller sizes depending on the architecture. But again, it's just another component that you've got to have when you're generating electricity. So they've got the turbines in. They don't currently have the generators. That's why they've got both reactors to build at Hinkley Point C. They've got the generators to build. One of the turbines is in. There's still a lot of work to do, and that's why it's projected to 2029. So yes, that looks good. It would be good, yeah. So following on from the UK steel stuff, this is China's response. So the video said that the public sector in the UK has taken over, or something of that sort, the Chinese company.
同英方开展了合作。对于目前英钢经营遇到的困难，双方应本着互利的原则商谈。
Okay, so they want to come to a negotiating table and
公平公正对待在英投资经营的中资企业。
Yeah, okay.
正当合法权益，避免将经贸合作。
They don't like their steel plant being taken over by the UK government.
正常投资合作的信心。
Okay, so here, British minister said that China's group wanted to shut the furnaces at Scunthorpe after the China group rejected the government funding proposal. So the government's just kind of gone, nope, we'll take it over from here. That just makes sense. Yeah, so that is our first look at industrialisation in the UK. Hope you liked it. That'll be all for now, I think.